A differential equation tells you the slope at every single point but not the function itself. Picture that as a whole field of tiny arrows. Drop a dot anywhere and it drifts along them like a leaf carried on a current. That picture is called a slope field, and it unlocks two big exam skills: matching a field to its equation and Euler's method. Let's see all of it. This is full marks. Today, differential equations and slope fields, how to see a solution before you ever solve it. A first-order differential equation gives di dx as a formula in x and y at every point on a grid. Plug in the coordinates, get a slope, and draw a tiny segment with exactly that slope. Hundreds of those little tick marks together make the slope field. Now drop an initial point and just follow the arrows, always moving in the direction the local tick points. The curve you trace out is a solution to the equation, and different starting points give you a whole family of solution curves. To match a field to its equation, the fastest trick is to hunt for where the slope is zero, the perfectly flat tick marks. Those zero slope lines pin down the equation almost instantly. Then ask, does the slope depend on x, on y, or both? If an entire horizontal row of ticks looks identical, the slope depends only on y. If a whole vertical column is identical, it depends only on x. When you can't solve the equation exactly, you can still step along the field numerically. That's Euler's method. From your current point, take the local slope, step a small amount in x, and update y by the slope times that step. Each step is just a short straight hop along the tangent line. Repeat it to march forward across the field. It's only an approximation, but it's exactly how computers solve differential equations. Exercise 1, a real AP question. A slope field is shown and you must pick the equation that made it. The trick is to find the zeros. The tick marks are flat along the y-axis and flat along the line y equals -1. So the slope must be 0 when x is 0 or when y is -1. That means it factors as x times the quantity y plus 1, which multiplies out to xy plus x. That's answer A. Exercise 2, also real, Euler's method. The equation is di dx equals 1 plus 2y starting at the point 0, 1 with step size 1/2, approximate f of 1. First step from 0, 1, the slope is 1 plus 2 times 1, which is 3. So y becomes 1 plus 1/2 times 3, that's 2.5, now at x equals 1/2. Second step from 1/2, 2.5, the slope is 1 plus 2 times 2.5, which is 6. So y becomes 2.5 plus 1/2 times 6, 5.5. The approximation for f of 1 is 5.5, answer D. Recap, a slope field draws di dx at every point and solutions flow along it. Match a field to its equation by finding the zero slope lines and checking x versus y dependence. And when you can't solve exactly, Euler's method steps along the field, new y equals old y plus slope times step. That completes the visual toolkit: limits, the fundamental theorem, volumes, motion, series, and now differential equations. Next, we put all of it together and solve an entire AP exam start to finish. That's next on Full Marks.